Good morning. So I wanted to go over some more about how to use this program when you're looking at basic inertial um, displacement, I guess. Inertial propulsion. I call it closed loop pulse propulsion, but again, that's kind of a misnomer. That's a really specific kind of movement. But let's start with the simple basic stuff. So let's find out if this program even works. Right. So what I've done here is I wanted to kind of show a few things. So this contraption down here, right? Is this going to fly out of its position in space and blah 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 blah, or is this thing here going to move one way or the other? And at this point, I'm just trying to show you the basics of momentum, and show you why things are doing what they're doing. And I'm using this program called Algodo, right? And it's just a simple 2D physics simulator, so this is nothing advanced. But for 2 dimensions, it's fine. Just imagine, a plate of glass over top of, these 2D woodworks, and nothing's allowed to come towards your face to a certain degree. I mean, they do a lot, certain wraparound things happen, like springs and ropes can wrap around things. So it does have a little bit of that unique binding. But let's just focus on the straightforward physics. So I hit play, right, and I've got the speed slow, so I can make it go fast, slow, whatever I want, right? I got no gravity, so I can turn the gravity on, I can turn the wind on, but right now we're just going to be playing out in space. I've got um, uh, what do you call it? The visualizations on, so I can see the momentums, I can see the velocities. And at times, if I want, I can put out a plot and actually show you when this thing completely stops moving, right? So we know it's going to stop moving because it's going to start at zero and end at zero because that's what things have to do. So we're going to, matter of fact, let's make sure that we take this thing and okay. So we're going to kick this one off. So when we start, this is going to smash into this block. This block is going to slide down here and hit this, but this is going to expand out, hit this, and push this whole thing this way. So these two are going to come together, and this is going to crash into here, right? And are these collisions going to result in a net displacement? That's the question. And actually, that's not even the question. That's just, are these collisions going to collide? Is this program working? Is it doing what it's supposed to do? So I'm just going to hit play. And so we can see that one. And we're going to go boom. And so 0 equals 0. See that? So let's go in as fine as we can. Right? It's as close as we can. Let's go into 0.01 second. 0.00001 second with that. Okay, so that is going nowhere. Huh. Okay, and I guess it shouldn't, because here's the thing. I mean, what did we do? We didn't transfer any momentum, right? So 0 equals 0. This thing did not move. Let's try it one more time, just to be on the 1000% safe side. So we start at 0, and the goal is for this one to end at 0 and hit boom. And it's 0. Okay, so we've gone nowhere. All right, good. So let's do the same thing for this one. You know what? Let's not do that right now. Let's just look at this for a second. Let's just watch how this works. So again, this is going to expand out. We got it going real slow, right? So let's just watch the dynamics and everything play out, right? We know this one here is not going anywhere. We're all set. So this one, we're going to hit boom, right? And that's kind of cool. Crack, crack, right? Now we know that this thing hasn't stopped moving yet. I mean, it might look like it's stopped a little bit, maybe. Yeah, see, it's still moving. We know it's moving because all this stuff is moving. And if this stuff is moving, the outer frame of reference has to be moving, right? It's only when all these things stop against one another can this whole thing be stopped? And we know that, when this stops, this is 0. When this stops, this too has to be 0. I mean, that's the rule, right? So now we know, well, this is still moving. Yeah, but it's moving up. I don't know if it matters. So we know that this thing has now stopped. So we now know that they're both just stopped. Good. So now I'm gonna, actually I don't even know if I want to show you that yet. But anyway, let's go ahead and put this back up here. Boom, boom, boom. And we're gonna go real tight, because I want to show you when this thing completely stops. So you go boom, right? And so it jumps up to 0.5 milliseconds, blah, 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 blah. And then we still got some space underneath here. So this is the distance between, to 0, and we still got some space. Okay, and let's go up a little bit more. Okay, so of course, let's go real fast till this thing hits 0. Okay, and I can speed it up as fast as to 1 billion. My computer is never going to let this thing go any faster than what that. So it's limited by my CPU. So setting it up to gajillions is nothing. Okay, so all right, so as these things are moving, right, which we know, I mean, we can see this is moving, so this has to be moving, right? I mean, it is what it is, and so stopped has to be stopped. I'm not really going to get into why it's probably never going to actually ever stop. And that would have to do with where the energy and the interactions combine. So in my theories, like I guess if you talk to like a physicist, they're going to say that this is going to violate the laws of conservation of energy and momentum. But if you accelerate this, so this has 0 effect, right? And that's because this one's going this way and this one's going this way. But they wouldn't have any effect anyway because they're not touching one another. So what? So like if I rearrange these dynamics so this doesn't hit that, right? And just kind of move it up and see if I can do it so these two don't touch each other, right? This impact shouldn't have any. So let's try it. So I'm going to move this up here. And since we know that has no impact, I'm going to just drop the size of this down. Let's try that. Okay. So this isn't going to do anything other than just move this to this wall. Okay. Actually, let's go to the other wall since it's a little longer. So the only thing I've done different is now I'm going to put a little bit of motion into this thing, but this thing is also going to go this way, right? So, but the question is will this move when these two collide? And I don't think it does. So let's find out. So we start at 0. These two are going to collide, right? And we're still at 0. Now we just gain some speed. You see? Okay, so watch. Watch. So we start at 0. We start at 0. Okay. So yeah. So when this thing starts out, so we're going to do this again. We're going to hit boom, right? No movement. But when this strikes, now we're up here. You see what I'm saying? So now we have some motion in the outside, but until we actually touch one another, none of this is doing anything, right? So these interactions aren't transmitting force until they strike something. So that's the idea. So let's go ahead and continue with this a little bit more, right? And say, now if I do this, right, now if I turn it on, boom, right? Now we know that this outer frame of reference is moving and this inner frame of reference is moving, and the assumption is that they're going to just go back to where they were at. And so this is kind of a clumsy one to explain. So we're going to just leave this as it is for now. We might come back to it. I don't know. But we're going to go down to another one somewhere. I got a bunch. Oh, there we go. Okay, so we're going to go to this one. Okay, so this was all linear, right? All right, so you can see that there's, when these strike, regardless whatever, it's going to shift its position. So this is thrust. See, this is thrust. Boom, thrust. Right? Now it's going to resolve itself. The theory is it's going to go right back to wherever it started and stop dead. Fine, or oscillate back or spin around or whatever it's going to do. Right? So um, that's the theory. So this is thrust. You don't have to like it. Okay, let me show you one more thing. So I'm going to delete this, right? And let's really give it some gusto. Give it a nice hard kick, springs, right? We're just going to put some stank into it. And then boom, right? Now we know, there's no doubt that the thrust event has happened, right? There was the thrust event. Not the second it leaves the nozzle, the second it hits this. Now, if it hits a back wall, we know it's going to get a second thrust event and it's going to go back this way, but that's thrust. That is not torque. Torque is a twisting, a spinning. Torque is this. Okay, so now we're going to go to this thing. So we're going to spin ourselves around and act like lunatics. All right, and so to do that, we have to just spin these things. And I'm going to look at the axles. And so yeah, these things are already doing their due when I hit start. So let's see what it does. So you can see we got some movement. All right, and let's get things really moving. Now, here's what's going to happen. You're going to get a bump, right? That's going to bump into that. That's going to bump into that. All right, so far so good, right? And if we kind of amp this up, right, fast as my computer can go, right, which is spectacularly fast. And so you can see there's nothing happening here. We're not doing anything. Is it moving? Yeah, no, it's not even moving. Just an optical dilute. Now it's got to be moving because I just bumped off of it. There's some way to speed these stupid things up. Hang on, because that's going too slow. Yeah, I've got the patience for it, but I know you guys don't. Oh, okay, yeah, so let's go. We'll speed them up, add a bit more of this. Let's drop it down to, make it lighter, because right now the default is this. So if we drop it down to here, so everything's just a little bit lighter, a little bit less friction, slightly more bouncy, right? And make sure we zero out all the velocity so we know everything is stopped, and just go boom. Okay, so now it's really going fast, right? Okay, there we go. Now we're squiggling around, right? Boom. Okay, that's beautiful. Now we know this thing's shimmying around, right? It's going to be shaking back and forth. But is it ever going to go anywhere, I wonder? I mean, can it? Where's the loss? Like, there's nothing escaping this thing. All you're doing is banging around inside the same area. Or are you? I don't know. Because there's times when these things interact against each other that doesn't have anything to do with the outer frame of reference. So if we speed this up even more, and even more, right? And again, we're just looking. We're not saying, we're just looking. Okay, and I'm kind of skeptical that this is ever going to go out of its position. Mainly because I think the physicists would have figured this out. Like, I think if it was just that easy. Now, a micro drift or two from this nonsense over here, I mean, it might drift out of, because, there's friction at play here. So you're not getting a complete and total that's kind of where I was going to get at, is there's friction happening. So the friction of the springs isn't going to really let this thing put itself back because the heat has kind of dissipated into the equation as well too. They don't do that in this dynamic, but that's why they've based this program on the Lagrangian mechanics, and so you can never. The Lagrangian ensures that you're never losing your momentum. I mean, it's literally the conservation of momentum. Um, that's what it is. That's when you take the Lagrangian, you are literally focusing just on the conservation of momentum, or the conservation of energy. Anyway, you're making sure, which is both. I mean, in this situation, momentum is energy. If you it's almost it's a direct translation. As you can see, we've been running this thing really, really fast, but just an insanely fast speed, and we've gone nowhere, right? So I'm going to call this one a bust, um, right? And so this is probably going to be here by the time we're done messing with this stuff. So I'm gonna leave that one alone because now you just see. So this is torque, right? We're just spinning things around, and it's never going to get us out of there. This is thrust, right? And again, back and forth. And I'm saying it's possible you could get a tiny little drift just because of the friction part of the equation. Right? So when you expand these springs, it releases energy, and that energy has to be accounted for, and that is accounted for by this program, which is why I like it because it does take the Lagrangian. So I know for a fact that this thing has to be true to the center of mass. And I did these dynamics to kind of just like show you that this has to be moving when these things are moving, and when this thing is not moving, well, zero equals zero. That's really what we're going for. So anytime we hit start, we know this one here is never gonna. Let's go back to the. There we go. That's the original start. So we know that's always every time we hit the start button, we know this one is going nowhere. We know this one is going back and forth, maybe losing a little. Who knows? We're not going to get into it. We know this one is going nowhere, right? So we know things now. We know what's happening, right? Okay, so now here we go. Here's another one. Here's another one. Um, so let's fix this because it's really, really stupid. Um, Wipe out the velocities. Okay. And actually, we can just, remake it. Let's get rid of that. Put on this. Drag it over here. And all this is that. So, but I did it off center, so you could see that this is just going to rotate around this, and so you're going to have these two things in rotation, and it's never going to go anywhere. Let's go ahead and really just get this thing fast as you can go. Fast and as hard as you can go. 450 RPM. No, you can go faster, but I mean, there's no sense in doing that. So there's a little motor on here, right? It's going to make this thing spin, right? And that's all it's doing. So going nowhere. Going nowhere. Now, if this program is, yeah, no, there's just no, you're going nowhere. It's just not something you're going to do. So, okay, let's get that back to normal. So now we know everybody's good. So this is going nowhere. We built a lot of things that are just going nowhere. This is going nowhere. These are going nowhere. Lovely, 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 lovely. Okay. For some reason, these things just don't look great. So we're going to reset this one, right? And I want to kind of show you a little bit of a dynamic here. And again, let's not worry about flying around out in space. So all I'm doing here is I'm just releasing this spring. It's going to pull it back, and this whole thing is going to spin around, and I apologize what it looks like. So boom, okay, boom. Why am I showing you this one? All right, so let's grab a piece of territory, show the plot, see what happens. Okay, and a lot of this is going to be twisting, so don't worry too much about it. Okay, now remember, let's see, a little bit of smoothing in there. Okay. Now remember, when this started, there was a bit of a tug. I don't know if I can do this one. I mean, that wasn't the idea. All right. So anyway, we're gonna just stop that. But you can work on this one on your own, right? So don't forget when this one started, it started down here, right? And it pulled this up, which means this thing shifted, right? And as we're watching, you're gonna notice this thing's getting a little farther and farther away. Let's go. I might have just clipped it. Oh, look at that pattern. That is just sweet. Right, but I mean, you can see. I mean, look at how beautiful this is. Let's change this out. You can see we haven't stopped moving. Now, of course, that's just rotation, right? Um, but if you look, now it's going to come back, and we're kind of locked into, this weird, strange orbit. And this center of mass here, which is where this point is kind of drifting away at the same speed that is drifting away from us. You see what I'm saying? So let's put this and go here. And let's see. So this center of mass shouldn't be drifting away from this line. What we can see is this drifts away from there, that's drifting away from here, which it shouldn't be, right? But again, again, you can make an argument that this doesn't mean anything. Okay, so that we're not actually flying around in space. But I wanted you to see this dynamic of how the spring, when you have to account. So the spring was start. So let's pretend that this thing is just held here with the latch. You hit start, right, and we're going to go real slow. You hit start, boom, right? That was a transfer of momentum. Boom, transfer of momentum, right? But there's also a transfer of momentum when this thing starts. So you get a transfer of momentum, and now it's going back and forth. So you get two transfers of momentum, and I don't know. You just, like I said, we'll get into all that later. So here's a similar contraption. So what is this thing? So let's go back. So axles. So all we're doing is just slapping a board. Okay. So what should this thing do? It's probably going to spin around this axle, and whack this thing here. So again, shouldn't do anything, right? So let's speed it up as fast as we can. We know we're going to get some kind of spin. Well, let's fix this because I don't want it to go through. And you can fix it by just thickening. So we got a little. I don't know if that's going to work. Yeah, we're okay. All right. So now we select it. So that thing shouldn't pop through anymore. Okay, boom. So all we did was put a latch over top of that hole, so this spring can now bounce in and out of this area much as it wants, right? And now all we should be doing is spin. Okay, so let's see how fast we can go. Go up, 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 up. Okay. Hmm. That's looking a little weird. Huh. Okay. So, is that because it's spinning? I gotta just get rid of that one. I am so sorry I even built built that thing. So that could just be from spinning, right? So, but we do see that it's moving away from this nonsense here, right? And we'll just accept that this is spinning, right? So let's go back. Um, we'll leave that alone. That's fine. Okay, now let's go to this one. Okay, and let's see what this one does. And we're going to go into, so I hit 3, that one goes reversed. I hit 4, yep, and that one goes forward. Okay, and then all that's going to happen is this thing's going to bang around inside the box. Right, so I hit 3, good, 4. Right, so now both are spinning. Nothing should be, you know what? I think, let's make sure, because I was running these earlier. And velocities, let's stop everything. So now everything is stopped. Boom. Now I'm going to hit 3 and 4. And now I'm going to go fast. Okay. So now this thing shouldn't do anything because these are just offset. But if I turn one of them off, I can make that go. All right. If I turn this off, I can make that go. All right. So now I have complete control over how this thing moves around. So if I want to crack that ball, right? Boom. So now I hit the ball. Now that ball's going to be going nuts inside here, right? So I'm going to turn this off. All right, I'm going to put this back into the position that I originally started in, right? And there we go. Now, we're back in the position that we started. Make sense? Well, we're not actually. What's happening? All right. You know what? I'm going to spin this. Get this ball really moving. Boom. 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 Okay. So, now we're back to stopped. Remember we were stopped, we were at 0. That has to be at 0. Well, actually no. Where would we be at? You see what I'm saying? What's going to happen when this thing strikes? Boom. We're still moving. Are we going right back to the exact same position that we were at? I don't know how that's possible. Let's see if we can go in. It's not going to go any faster. Actually, we can make it go faster. Here, make it go faster by making a lighter ball. Go here. Make it bouncier. Restitution is just how bouncy it is. Bouncy, bouncy. So it's a big bouncy ball. Okay, so we turn on, and you know what? Let's go to Go to boom and axles, and let's make everything really fast. That should do it. Axles. Well, you know what you got? Let's go to 150 and 1,000 because you have to get them exactly the same, otherwise they're not gonna. So 150, and this doesn't matter as much. So boom and 4 and 3, 4, 3, and oh yeah, much faster. Okay. So now let's go back and put on a plot. Okay. So you can see we're going nowhere, and actually let's do a complete pit stop. Velocities. Okay. So what's moving still? Nothing really. Okay, these are just oscillations in the system itself, and because it's 2D, you can't really isolate it. But anyway, so maybe let's see. Boop, 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 boop. Okay, so we're just seeing some oscillations, but nothing major. There we go. Now it's turning at that speed. You can see it's moving, right? But it's not doing anything. It's cool. Okay, and you can see it's gone up a little bit. Let's get this closer. Okay. There we go. Boom. Okay. 1, 3, 4. Okay. So there we go. Now we're stopped. Okay. And the idea is we want to wait till this thing goes back to its original, like everything kind of goes back into shape. So the question is, are we just rotating? Or are we moving? And again, I'm not going to get into that right here. I'm just going to say, probably not. We're probably not going anywhere. It doesn't look like we're going anywhere fast anyway, right? So I think we might be drifting a little bit. Feels like it. If you look at this up here against the two, you can see we're drifting, right? But so is this ball, and it's just this ball is drifting. We have to be drifting. But anyway, this is confusing. It's hard to tell what the hell this is doing because, the drift is so slow, it would take you forever to get anywhere. So let's increase this to 1,000. Right? So you're not really going anywhere. Not really. These two are coming together. Coming together. So again, just an experiment. Just an experiment. Right, let's reset everything back to the way it was. Make sure everybody's good. You're good. You're still banging around out here doing nothing. There's my buddy. Sorry about that one. I don't know what happened. Okay. Now we got this weird little contraption. Okay. So let's hit play. Going nowhere. All right. So my assumption is this is going to be 1 and 2. Axles 2 and 1. So we're going to hit this, and we're going to go just 1, right? Boom. Kind of kick up the speed a little bit, and then hit 1 again. That's it. Something seeming wrong here. Wait, what's happening? Come on. Is this program that terrible that just that tiny little bit of motion could knock this thing right out of orbit or whatever the hell you're talking about? I mean, we just gotta be spinning, right? That's spinning. Let's go faster. Boom. That's about as fast as my computer can go. All right. So clearly we're going to come back, right? Papa! Papa, come back! What was that? Romancing the Stone, where Danny DeVito's like, come back. He's like, I'll come back for you. He's like, you're coming back. He's not. This is not coming back. This is not coming back. So what the hell just happened? I mean, I did nothing. I literally did nothing. Right? So we're stopped dead. I'm going to go as fast as possible. Boom, boom, boom. Right? Oh, you know what? Maybe it was already moving. Let's maybe that was the problem. Maybe I'm cheating on this one. So let's go here. Boop. There we go. Hey, that was the problem. Okay. Now we crank everything up, and we're going to hit 1. Okay. Uh-oh. No, it's still moving. So clearly I had some motion in it from the last time I ran it. But if you keep doing it over and over and over again, see, watch. It goes faster and faster. See, that's not supposed to do that. You understand? So we have a problem. Maybe this program can't handle these crazy dynamics. Can it not handle 2 springs and 2 balls? Right? Maybe it's this program's just terrible. Right? Because clearly I do that. And yeah, this thing rotates like it's supposed to. Right? But it also continues to move. Why is that? And how did I know it would do that? Boom. Boom. I don't know how to drive it, but I can make it do all kinds of crazy stuff. Now, you take this one and okay. Now you take this here and you can actually go woo. Yeah, let's select the whole thing. Let's spin it. Right. Okay. Let's build it how I built it originally. We're gonna take it out here like this. That needs to be spun. These need to come down here. Right. We're gonna take this. And I did it like this originally, because originally, actually, the original one was that big long. This was the one I started with. And yes, this it is what it is. So I started with this one, and I had the balls hanging off here. I got some latent issues. All right, so we're gonna start this one up. Everything's gonna kind of just settle in, right? That's fine. Now we're gonna select all this and stop it all, velocities. Okay, boom. Now nobody's moving. All right, so then we're just gonna okay. Okay. So just the slight drift here. So what are we looking at? Are we actually going to be like, flying around like the Jetsons with this? No. This is why no one's noticed this on Earth, because it's nothing, right? You're getting a tiny little shift out of your position in space, right? You can't do this on Earth because friction is holding you in place. But out in space, you don't have the friction to hold you in space. And this whole program, like I said, is built on Lagrangian mechanics. So if this thing is moving out of its center of mass, it's because it's moving out of its center of mass. It's gotten a thrust. You can't move out of your center of mass without a thrust. And we clearly went over what a thrust is. When this thing is smacking into each other, this gets thrust this way, and this gets thrust that way. It just is what it is. So you get two thrusts, one this way and one this way. The problem is these two also get the thrust. So when you start the system, right? So we're just going to start it, boom, right? And then stop it. These two also get the thrust. Both of those two get a thrust. This gets a thrust. Everybody's thrusting right now. Nobody. Well, this is torquing, but this is torquing and creating a linear momentum. So this is a linear accelerator, sort of, by using the torque of this to drive linear momentum in this thing. And again, it's not great. It's not perfect. It's not straight up and down, but that is translating a thrust to here. This is translating a thrust to here. And so as this bangs back and forth, but the problem is, as these two balls, they're not taking they're changing the way that the equation is interacting with this entire system. So the equal and opposite reaction is there. It's absolutely equal and opposite. It's just asymmetrical the way that it tallies up at this juncture here, where these things slam together. You're just getting an asymmetric force because as these two clack together, they're not able to redistribute the same force back this way. And that's just it. So turn that off. Okay, and we watch. Okay, so everything's stopped good, but it's still not stopped, right? I mean, when you watch these minuscule momentum transfers, right, you'll see that this system is absolutely acting just fine, right? This linear momentum that's being, it's being pulled this way, it doesn't have the same force as when it pushed it away because these two have clacked together in the interim. They just changed the momentum equation. They have to. You have to account for these two balls anchored to this system. And now when you look, you see everything is still moving. It's still floating away. Again, I'm not saying this is, you're not rocketing out of your position in space with this, but you are moving out of your position in space. You're never going to put this thing back to where it was. You cannot. And it's going to just keep floating and floating away. So it has nothing to do with gravity or anything else like that. There's no mutual attraction pulling it. It's literally just from all of that energy that we put in when we were just, not allowing it to see, watch. Yeah, that's going to settle. You see it's moving. That's going to, it's just going to make it go faster. So that's inertial propulsion right there. This is actually closed loop propulsion because it uses angular momentum to create the effect. Now there's the linear propulsion that you can do too, but that's really just, it's not great because you can't really, amp that up. Once you get the hang of this and understand how you can create this effect, let's go back. Okay, that's good. All right, so now where are we? So now we got another, and I don't know if I'm going to do that other one above it. So now we got this monstrosity. All right. We do have to go all the way back. I gotta launch this. There we go. So now we got this baby right here. So what is this? This here is two plates. Plate one has a spring on it that pulls it and pushes it. So it's going to push this up this way. And then this one is going to do the same thing, but I didn't really arrange it. So this is going to push this one up this way. These are just two rubber arms that can slap together any which way you want. All right, and so they're also on motors, but right now the motors are free. And let's see, axles. So 8 will stop. We'll change. We'll make this one go up, and 9 will make this one go up, and 10 stops them both. Yeah, 10 stops them both. So 8, 9, stop. All right. So wooden platform, springy rubber baby bumpers, and let's see what happens. Boom. Okay. So the platform's going down. Speed it up a little bit. Watch the dynamics. Let's just see what it does. Leaving it alone. Okay. Well, it's spinning now, I guess. Okay. See if we can get going any faster. No. I deleted all those other ones. So these two are going to come together. And I could just give it a little bit of a juke, but I don't really want to right now. Just want to see how it plays out. Okay. And as we know, this one's definitely going to keep moving until they strike each other. Now they're going opposite, right? Fast as we can go. But like watching paint dry. So we know this is still going down. Well, this one's going up. If I was to hit 0, it would probably stop this whole thing, right? That's still moving. I'm going to hit 0. We're going to stop those arms from moving. Just make sure. Yeah, there we go. See how that stopped? Those arms are stopped. Everybody stopped. Good, 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 good. That's what we wanted. So let's go back. Let's go here and stop. Good. Everybody stopped. Okay. Let's go and put on our plot and make sure that we hit stop, stop. And it goes here and stop. Stop. Let's go closer. Stop. Weird. So it didn't stop. All right. So we know it's got to stop though, right? Because we hit 0, right? Well, it did stop accelerating. That's for sure. Well, here let's give it. I'm gonna hit 8 and 9. Let's remember 8 and 9. We'll make them come together. Boom. Right. And then 8 and 9. Boom. I'm just doing when they strike. I give it a little extra kick. So it strikes, bounces back, and give it a kick. Okay. And then once it gets straight back up, we're gonna stop it. Right. So that will stop them together. Okay. Good. 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 Now this has got to stop. Well, no, it just got faster. It did stop, but something's still moving. What could possibly be moving? Well, actually, it's this thing. This thing's got to be moving. So it's got to be spinning. That's what we got to be. That's what we got to be seeing. It's a slight spin. So let's go back. Um, 8, let's go 0, 8, 9. Boom, boom. 0, 8, 9. Boom. Boom. So on the upward stroke, I bring them together harder. And so I push energy in, let it bounce together. Push energy in, let it bounce together. I push energy in, let it bounce together. I push energy in, let it bounce together. I push energy in, let it bounce together. Push energy in and let it bounce together. Okay, now that should stop it. And we're going to hit 0. There we go. Interesting. So what is this doing? I mean, nothing really. It's not really going anywhere. What's it doing? Okay. So let's do a rework. Okay. Because clearly that is not going anywhere. Right? So let's take a plate. And we're gonna make it kind of unlevel. Right? Best we can. And what do we want to do? We just want to offset this thing a little bit. So let's make this material out of, that's fine. And we want to put a little bit of springiness in its step. So 0.3, I guess it doesn't matter. Okay. And here we want to make sure that we don't let it go too far. And so let's see what happens now. Ooh, little spring in its step. Remember, we've off-balanced the equation a little bit. Just a little bit. I don't know why I even try that. Okay. So as this continues to, what's it doing? This is moving. Okay. Which makes sense. You know what? Let's slow this one arm down a little bit. Let's add a little bit of add a brick to it. Brick. Okay. Turn it into rubber. We just need a little bit more weight, I think. Just to offset that spring. And boom. Yeah, there we go. Okay. Ooh, good hit. Okay. Interesting. Slow. This has been a. You really have to have a lot of patience. Um, hmm. Okay, so now we should be stopped. Well, no, actually, this is. You know, I'm gonna hit 0. Okay, so now we are stopped. Let's make sure. Are we stopped? Yeah, we're stopped. Okay, so let's see if we can't add a little bit more to it. Let's create a little bizarreness. So, I like doing it. Oof. Boom. I'm gonna hit 0 because it's gotta stop it. Okay. Boom. Well, I think we need to increase the weight of this thing here. Turn it into a speck of gold. Boom. Oh, that's bouncing off of there. That's cool. Okay. So, interesting. So the question throughout this whole thing is, um, you can see that this is, how do I describe it? Um, Absolutely moving out of its center of mass. And the dynamics in this system are not remotely difficult to emulate. You can create them on just about any simulator out there. It doesn't need to be just 2D. You can do it 3D. But you can see that this system is never really going to stop. It's never going to put itself back into position. And the more that you keep adding in, let's see, 8. Here, start. We go boom. Okay. Other one. Bring it up. Whack. Okay, so I'm just going to add energy to try to control where that ball is going. Alright. Wham. Boom. Uh-oh. And of course, you can play with the different masses and things like that, and different velocities. Really kind of kick this thing around. But the idea of gold might be a little bit too much. Yeah, I think that gold's too heavy. Material, steel, over. Boom. Now once it's up, you add energy. Actually, you know what? Let's increase the speed of these things too. Oh, they're super slow. No torque. Oh, I was just playing with it. Super slow. No torque. Okay. And boom. There we go. Drive a little bit of gas. Oh, look at that. Oh, that's not going to work. Boom. Ooh. Interesting. Oh, that's a cool hit. Yeah, I don't know what that's going to do. That is super cool. Hit 0. Now everybody stopped. Hit 0 again. Boom. There it is. Come on. Alright. Clearly not going out of our center mass that way. Let's try. Chain. Ooh. Interesting. Okay, and no. Ooh. Like that. Douche. Yeah, I'm liking that a lot. But